All right, hello class. Welcome to week 13, I think it is. So this week's topic is wildfires. As you know, this is the last topic that we're covering in terms of actual chapters within the book. And then after this topic, you guys will have your third exam, which will cover chapters 9, 10, and 13. Okay, so that's going to be the atmosphere processes and severe weather chapter, the hurricanes and extratropical cyclones chapter, and then the wildfires chapter. Okay, after you complete the exam 3, there's going to be a week that is completely devoted to your class project. In case you guys haven't gotten very far on it, you are definitely free, and I encourage that you actually ask me questions either through email or go to my office hours in Nampa, in the academic center, in order to complete that class project. That class project has to be submitted again through the signature assignment by December the 7th at midnight. Okay? All right. And after that, you guys will have your final exam. Again, I will be posting more information on this. It's going to be either an online test or a in-person one, so you can choose which modality you want. But there will be certain conditions about it. So I'll post more information on it later on. I'm also thinking, guys, if you are interested, of making another module, and this is going to be based on chapter 14. So that's going to be, I think it's called Impacts and Extinctions. So partly I'm making it because I'm interested in it, and partly it's going to be a full extra credit weekly module. So I'll put it out there. Hopefully I'll finish by the end of next week, but it might take me a little bit longer than that. So if you have gotten far within your class project and you finish exam 3, and then you have kind of like an extra week just to ponder all the material that we've covered, then you may be interested in covering more material on that extra credit weekly module. So that would provide you with an extra, I think, 50 points, more or less, of extra credit opportunity. So keep an eye out for all those announcements on all the different things. So again, this week, wildfires, it's not going to be a super long chapter, so stay tuned. Right, so introduction to wildfire. So wildfire has been one of nature's oldest phenomena. It's been going on pretty much since the evolution of trees inland, which was about 350 million years ago. About then is when trees were actually able to spread throughout the whole land. So that we've had wildfires ever since we've had fuel for them to ignite. And we'll come to all those words later on. The nature of wildfires, however, changed a little bit once grasses evolved. So grasses evolved about 20 million years ago. And grasses, because of their nature, they provided a different source of fuel for these forest fires. So grass actually burns a lot faster than does like forest and woody areas. So with the grass development, the overall wildfires intensified a little bit. And again, they intensified after the last glacial maximum. So the last glacial maximum actually happened 18,000 years ago, but the last bit of the glaciation, which is when the start of the Holocene epoch happened, was about 11,500 years ago. So once this time came, once we no longer had very large ice sheets covering the northern hemisphere, is when the overall wildfire activity kind of intensified again, as we could see it. And this is seen in the sediment record since then, which basically helps us know that the retention of charcoal, for example, was very high starting after the beginning of the Holocene period, or epoch, sorry. So before humans were around, whenever there was a wildfire, it would pretty much burn until it ran out of fuel. And these were usually caused by either lightning strikes or by a volcanic eruption material that ended up heating up whatever woody or grassy area was around. So wildfires actually got to be such a common phenomenon that tree species started adapting to fires and using it as an advantage. So some of those adaptations were that certain trees actually have very strong kind of bark, so it will resist fire. Those trees would be something like oaks or redwood trees, for example. Another way in which those adaptations took place was through the seeds of these trees. So some of the pines, for example, the lodgepole pine, and I think actually sequoias also do this, their seeds are inside of the pine cone, and there is no way for the pine cone to open up and release those seeds unless it's heated up to extreme temperatures that would only be caused by wildfires. So basically the continuation of the species only happens if wildfire goes through that area and basically opens up the pine cones to release those seeds. Excuse me. So fire actually helped humans and species development. So it led humans to harvest fire and keep warmth as we were developing as a species itself. And it also led to better cooking practices, which helped avoid diseases. So overall, it didn't just let us spread further, but it also helped us live longer. It also let certain animal species thrive in areas where new vegetation would grow after the fire had burned through that, right? And it is known that by Native Americans, for example, and any natives in the Americas, not just in North America, fire was used very much so for hunting, agriculture, and warfare practices. In South America and Central America, it wasn't used as much as in North America, from my understanding. And this is partly because of the vegetation and the different cycles, basically the different seasons that were experienced in either hemisphere, basically. So from these, I want to mention two major fires. One is the Peshtigo fire, which happened in 1871, and this happened in Wisconsin. So only in 2 hours, that fire burned 1,000 kilometers squared, and it took about 1,500 lives. They're not very sure because it was so long ago and it was hard to record, but it could have even taken 2,500 lives. So that's a lot of people who died in this fire. The way that this fire spread was by abundant winds that happened in that area, and also by the amount of fuel that it had, the amount of wood that it had available. Also during this year there was a drought, which didn't help the overall relative humidity and the soil moisture to basically extinguish, or not extinguish, but not let the fire spread. So all of those factors helped for the fire to continue on and grow as quickly as it did. So this fire wasn't just aided by the winds, the fuel, and the drought, so not just natural influences, but it was also influenced by poor logging practices and also by the poor storage and treatment of the wood that had been cut. So the terrain that the wood had been cut was cut because they were expanding the railway, for example, and also constructing a lot. So the areas that they were cutting, they're basically putting all this cut wood next to wherever they had just logged, and so the fuel, which is the wood that had been just cut, remained in the forest, all piled up, basically. So if there had to be a fire, it would definitely find a source for it to continue on, to still live, if you would. So again, although all the natural factors influenced greatly, it was also helped by human practices. Another big fire, which was greatly influenced by humans in this respect, is the Indonesian fire in 1997 to 1998. So this actually was kind of like a year-long fire. So this took place in the islands of Borneo and Sumatra. So again, those are Indonesian islands. A little bit of Borneo is Malaysian, but I think that most of the fires were still in Indonesia only. So again, there were many fires, and most of them were deliberately set to clear land and this land was cleared by, if I'm not wrong, by palm oil kind of growth that they were trying to get. So they used to clear the land of any other sort of vegetation, and this is again by humans. And then, however, they were clearing this land, they didn't have a good prescribed burn, and so it pretty much got out of hand because of the drought that they were experiencing, and so the fires intensified and continued on. So again, during the 1997 year, there was El Niño phenomenon going on, which led to a drought in that fall area of 1997. So there were no rains to basically extinguish the fires that had started and gotten out of hand. So the fires actually went on from May of 1997 till April of 1998, so almost a whole year, which is crazy. Overall, this is kind of believed to be one of the worst fires in history, or at least as much as we have recorded. But it burned 100,000 kilometers squared, which is close to half of Idaho's area. So just think, half of Idaho basically burning. That would have been the size of this fire. So finally, in April of 1998, the fire was extinguished by the heavy rains. But again, a whole year of that. So it obviously, because it was burning for so long and it was so massive, it caused many human health hazards in, again, respiratory, vision, skin areas in your health. And this happened not just in Indonesia, but also in Malaysia and Singapore, which are the closest two countries. And the smoke itself from these fires reached all the way across the ocean to Thailand and also to the Philippines. So it was very, very major. In fact, the smoke from this made one of the airplanes, the jet airplanes, crash against one of the mountain faces because of poor visibility. And with this airplane crash, there was another 234 people who died as a cause of this. Also, wildlife, for example, was forced out of the forest, obviously, having no other habitat. Orangutans were the main species that was affected by this. And orangutans, as you may know, only live in Borneo and Sumatra. So their habitat was completely, exposed. And as orangutans were coming into, cities, because there was the only place that wasn't burning, people were unhappy with them since they were looking for food. They would usually, go through their garbage and ravage and whatnot. So people started killing the orangutans as well, which did not help at all. So that's why I have those two pictures of the orangutans fleeing the forest fires and then different organizations helping them out. Okay. So wildfire as a process. So wildfire, the definition of it is going to be a self-sustaining, rapid, high-temperature biochemical oxidation reaction that releases heat, light, and other products. So in order for a wildfire to live, to continue, burning, it needs three things. It needs fuel, it needs oxygen, and it needs heat. In the absence of any one of those things, the wildfire will be extinguished, basically. Okay, so essentially in a wildfire, you have the reverse process of photosynthesis. So it is very much so like rotting or decomposition, which again would be at a minor scale. Wildfire, it is at a greater scale. It's decomposition at a very fast scale, basically. So when a wildfire happens, it speeds up this decomposition process. So in a simplified view, when it burns, it will release carbon dioxide, water vapor, and also heat. But in truth, there are more compounds, both or in solid, liquid, and also gas forms that we should probably look into. So some of the trace gases, for example, that are released are things like methane and other hydrocarbons, also nitrogen oxides, carbonyl sulfide, carbon monoxide, and then methyl chloride. Some of the solid particles that are released during a wildfire are things that you may be familiar with, which are ash and soot. So ash is mostly made out of mineral compounds, and then soot is actually mostly just unburned carbon. So those are some things that we have to take into account.